Hey, good morning, everybody. Hopefully, everybody had a good weekend. One thing here, hopefully you took a look at your test. Always look and see if there's any comments, any marks on there. Just go through there, double check everything. Okay, if you got any questions, come today to Canvas Conference, 12:30 to 1, and maybe I could answer anything individually for you. Hey, just in case here for the weekly schedule. We are going to, I know we only did 7.1 to 7.5 on the test, but we're going to finish the last two sections of chapter 7, 7.6 and 7.7. So as we go through here today, we got section 7.6. It's going to take us 2 days. So you get your video notes and your assignment. Tuesday, okay, section 7.6, day 2. And then Wednesday and Thursday will be section 7.7. So you got day 1, day 2. Now we still got your Canvas conferences like normal. You need any help, any issues there, every now and then I'll put out a different problem than what we went over in the class. Friday, we're not going to have anything, no video or assignment. And then Monday, we're going to start section 8.2. We're not going to quiz over the last two, 7.6 and 7.7. They will be on the final. Okay, so you do have to know them, but we're not going to quiz on them just because of timing of everything. We need to get through our next chapter. Now, here's how the next chapter works. We only do one section out of chapter 8. We do 8.2, and then we jump into chapter 9. And they're all together, and we will have a test over those. Basically, we call it a chapter 9 test, and we'll get to that next week. All right, let's get started here. We are going to do polar coordinates, which these things are totally different because you usually haven't seen them to this point. And, for me, they're actually kind of fun. But, I'm a little bit of a geek. But we're going to plot points using polar coordinates. We're going to convert between polar and rectangular. And then the fourth one here, polar equations. That's what we're going to do tomorrow. Okay, we're going to graph those. And those can be kind of interesting. But first, we got to understand what polar coordinates are and how to use those. Okay, a point P, all right, here's how the basic definition goes. And hopefully I keep forgetting to do this, and hopefully you've gotten to the point now where you're used to it. There are guided notes. Okay, if you go to the modules to get to the video, hopefully you saw the guided notes above there. Okay, print those out if you can. You don't have to, but it's very helpful to keep a hold of these. And now, for the guided notes, a point P in the plane is described by an ordered pair of numbers r theta. And we refer to r and theta as polar coordinates. Now, to help graph, this is a polar graph. Okay, as you see here, this object, this spider web looking deal. Hold on here, let's see if I can pull these down. This spider web looking deal is a polar graph. And here's how it works. A is 3. The point A is 3, 30 degrees. Well, your degrees are just like a direction, okay, like we've been using. 3 would be a radius. So these are equal radiuses. So going from the origin out, that's 1, that's 2, that's 3, that's 4, that's 5. That's tell you how far out to go from the origin. And this is your degree. So point A is 330 degrees. These are in your typical unit circle, except the 45s aren't here. So this is 30 degrees. This is 60. That's going to be 90. That's 120. That's 150. That's 180. 210. 240. 270. 300. And then 330. Now you can have any degrees, but those are the only ones that are marked. You can talk about 10 degrees. You just have to estimate where that's at. You can talk about 140 degrees. You just have to estimate where that's at. So for 330 degrees, you go to 30 degrees and you go out 1, 2, 3. And I'm going to put a dot there. And that is the point A. For 135 degrees. Well, 135 degrees isn't marked with these, as you can call them spokes. But it was where the 45 is, and it'd be right halfway in between there. So 435 degrees. 1, 2, 3, 4. would be right here. That's point B. All right, negative 260 degrees. This is now we're dealing with this a little bit differently. Okay. Because if you look at B, that's 435 degrees. That's over here where we're used to having a negative x coordinate. Here's how we deal with the negative radii, and that's kind of that first term is the radius with polar coordinates. Go to where 260 degrees is. And the negative means we just go through the origin back to the other side. And so right here is going to be C. Okay, that's how we do negative 260 degrees. And if I have three negative 60 degrees, all right, just like when for a negative angle, a positive angle, we go counterclockwise. For a negative angle, we're going to go clockwise. So three negative 60 degrees would be, you go out 1, 2, 3, and then you go to 60 degrees. And that's going to be D. Now, since we're on video, it's a little bit harder to explain. I'm going to do one more before we get to the next part. I'm going to do E. And what if they're both negative? What if I get negative 3, negative 120? Okay, here's how we graph that. Go to the angle first. So we go negative 120. So there's 30, 60, 90, negative 120, and we are at 3. Now, the negative 3 makes me go back through the origin. And I go to this spot here. Well, if you haven't figured it out yet, you can name a point with multiple coordinates and still be the same. And that's what we're going to go through next. So this point B, I could have named several different ways, and it still would be at that point. Point C and D, the same thing here. Okay. You can name them with positive radii and then positive angles or negative and negative. So let's kind of go to that next part there on your guided notes. So what I want you to do is I'll go ahead on that same, you have that one graph right there. Go ahead and graph. You've already graphed those other ones. This should not be at the same spot. Graph 3 to 10. And I'm going to graph it here. And I'm going to move this out of the way. Right, 3 to 10. And that is going to be the point P. And that will be right here. Now, there are 3 additional ways to name this. Every point can be named 4 different ways, and it still represents the same point. And they give you some conditions here, and I'm not going to, I will just show you how to name the 3. Now, the first one where R is less than 0, and you have a positive angle. All right, so we want, again, we want a negative radii and a positive angle. So for that one, essentially is, so the positive angle, negative radii, that is going to happen when I go to this angle and then I go through here. And sometimes it's easier, just let me write it down first and then I'll discuss it. So negative 3, 210. So not 210. Negative 3, 30 degrees, sorry. So negative 3, 30. So if I go to that, go to 30 degrees, positive 3, and then the negative 3 tells you go through the origin back to the other side. It's always going to be 180 degrees difference when you do that. So negative 330 is the same as 3210. All right, so part B, let me move this over. It says R is less than 0, so it's a negative, and you have a negative angle. Okay, R is less than 0, and you have a negative angle. So let's take a look at that. That's going to be, and this is might be the more difficult one to figure out initially. So I'm just going to write it down, negative 330. So you start here for a negative angle. We go this direction. So I go all the way around to this point here. That would be the point 3, negative 330. Well, since it's a negative, we go through the origin to the other side, and that puts me back here. So the point negative 3, negative 330 is going to give me that same point P. Okay. And the last one is C, positive radius, negative angle. So we don't have to go through the origin. We just have to get to that spot here, but we're going through the negative angle. Well, what is that angle as a negative? So 30, 60, 90, 120, 150, negative 150, 3, negative 150. Now, I really don't care. I know it has this A, B, and C. I really don't care what order you find them. Okay. You just need all three of them. One of them has two negatives. One of them has two positive, which is the first one we listed. And then you have a negative radius, and then you have a negative angle. Okay, you just need to list all four. It does not matter what order you go. All right, so what I want you to do now is you try that with this point here. See if you can come up with the three other names for that. I'm going to pause this for a second while you do that. All right, we're back. Q is 490. So let's just plot that first. So you go to 90 degrees, 1, 2, 3, 4. Here's point Q. We need to name it three other ways. Like I said, it doesn't matter what order you go, because personally, I'm just going to go through what my process is usually I'm going to, at 490, I do the negative angle. So how do I get to that spot going negative? Okay, so from here. So I'm going to go all the way around to here. And that's negative 90, 180, negative 270. So that is the same as 4, negative 270. Okay, normally that's the one. I know it's the one we found last. That's usually the one I'm going to find first. And now you got the other negative angles, either a negative radius. So we're going to go here. And that's going to be, we're using a negative radius. We're actually going to think over here on this other side. So I need to be here. And I have to have a negative radius, and I have to get to here two ways. I can get here with a positive angle, and I can get here with a negative angle. Well, the positive angle is going to be positive 270. So in this case here, it's going to be negative 4, positive 270. Okay. And then once I get to that negative 4, it makes me flip over to the other side. And now I have to get to that spot with a negative angle. Well, the negative angle, we go clockwise. That is negative 90 degrees. So I got negative 4, negative 90 degrees. You just need to list all three. I really don't care what order. Okay, don't worry about, even in the book, I think for the homework problems, they have a specific order. I don't care. Just put all three of them down. So any point can be named 4 different ways, and we're still naming the same point. So it's a little bit different than what we're used to. All right, now polar, let me go back for a second. This is a polar grid, but you could overlay a rectangular grid on there, and you can name any polar point with rectangular coordinates and any rectangular point with polar coordinates. Okay, so like this point Q right here, that would be the point 0, 4 in rectangular coordinates. That one's an easy one to do. But we need to be able to convert between polar and rectangular. So let the positive x-axis of the rectangular coordinate serves what we call the polar axis. Okay, so the positive x-axis, that is this right here, that is the polar axis. And the origin as the pole for the polar coordinate system, because basically for the origin, that's where we're going to get our radius. Each point P has both polar coordinates, r theta, and rectangular coordinates, x, y. So any point right there, this point, we could label it x, y, or we could label it r theta, and they're equivalent. They name the same point. Well, the main thing we have to do is now convert between the two. Okay, given a rectangular coordinate, what's it as polar? And given a polar coordinate, what's it as rectangular? Okay. Well, if you take a look here, think about relationships. And if you drop that perpendicular down, we have a right triangle. So here's how x, y, and r are related. x squared plus y squared equals r squared. Okay, now, we want to relate the angle to the situation here. So the sine of theta is going to be opposite over hypotenuse. So the sine of theta equals y over r. Cosine of theta is going to equal x over r, adjacent over hypotenuse. And now tangent of theta is going to equal y over x. Now this is going to come back in a second is to be our reference angle. So this right there is going to be the inverse tangent of the absolute value of y over x. Okay, typically we cannot find an angle bigger than 90 degrees directly, but this will just give us that reference angle. So this is basically the setup we're going to use to figure out to convert from rectangular to polar and polar to rectangular. So now sine of theta, if you solve this one for y, I want you to think about that. That means y equals r times sine of theta. And for cosine of theta equals x over r, if I solve for x is going to be equivalent to r times cosine of theta. And then here, r is going to equal the square root of x squared plus y squared for this. Now let's just be a little bit more formal here, identify exactly how to do this. So to convert from polar to rectangular, if we know the polar coordinates r theta, and we want the rectangular, we're going to use x equals r cosine theta, y equals r sine theta. Okay, just like we talked about here, based upon this right triangle. Okay, I can set cosine theta equals x over r, multiply both sides by r, x equals r cosine theta. Same thing for the sine. Multiply both sides by r, y equals r sine theta. So this is basically our conversion. All right, let's take a look at a case here. Convert the polar coordinates of each point to rectangular coordinates. So now I got 3, 150. Well, what did we say? We say x equals r cosine theta and y equals r sine theta. Now just substitute those in. So r is 3 times cosine of 150. Now, if this is a unit circle angle, 150 degrees, multiple of 30 or multiple of 45, something we can do exactly. We're going to do it exactly. Okay. So what is the cosine of 150? Well, don't forget your rules over here. Let me just draw that out. 150. Oh, let me redo that. Would be right here. That would be a 30-degree reference angle. So that means the opposite is 1/2. And this is going to be a negative because we're in quadrant 2. So the cosine is going to be, so 3 is our radius, negative square root of 3 over 2. Now that just means if I multiply this together, nothing really cancels. I can just write that as negative 3 radical 3 over 2. That's all I'm going to do for that one. All right, now for y, it's going to be r times the sine of theta. R is 3. Sine of 150. Well, what's the sine of 150? It is positive 1/2. 3 times 1/2 is just 3/2. Now I can list this as an ordered pair. So the rectangular coordinates are negative 3 square root of 3 over 2, comma, 3/2. Well, not a very nice point, but there's nothing we can do about that. Those points are equivalent. If that is a radius of 3, that point right there, and this is an angle of 150. To get there using x, you would have to have a negative x coordinate because we're in quadrant 2 and a positive y coordinate. So that makes sense. Now for part B, same thing. X equals r cosine of theta. Y equals r sine theta. All right, where is negative 4 pi over 3 at? Think about that. Okay, let's think about which quadrant that's going to be in. negative 4 pi. So go to 4 pi over 3. Well, pi over 3 is 60 degrees. I didn't draw that too well. 60 degrees. And then you're going to go out 4, but it's negative 4. That means we flip through the axis, so we're going to be back here. Okay, and that's going to be a radius of 4. And we're going to be in quadrant 3. Well, you don't need to worry about any of that. Okay, it'll automatically work out. You just plug everything in. So for x equals r cosine theta, it's negative 4 cosine of pi over 3. We'll figure out cosine of pi over 3, because if that's 60 degrees, opposite is square root of 3 over 2, adjacent is 1/2. Cosine of 60 degrees is going to be positive 1/2. So you get negative 4 times 1/2, which is negative 2. Y is going to be negative 4 times the sine of pi over 3. And so that's going to be negative 4 times square root of 3 over 2. Well, that's going to be negative 4 square root of 3 over 2, but those cancel. So I get negative 2 square root of 3. All right, so that's my point. Negative 2 square root of 3. It should make sense that that isn't two negatives because it has to be in quadrant 3. Still use whatever angle they gave us. They gave me pi over 3. I take the cosine of pi over 3. I take the sine of pi over 3. And then I use the r as my negative. Okay, so you get negative 2 square root of 3 for your final answer. So that's converting from polar to rectangular. Okay, now go in the opposite direction to convert rectangular coordinates to polar coordinates. Okay, you need to understand what quadrant the point lies in. That's helpful. So you got to figure out, is it 1, 2, 3, or 4? So use now to find the r value, use r equals square root of x squared plus y squared, because that's basically you're dealing with Pythagorean theorem, because that's going to be y and that's going to be x, and there's r. And here's theta. To find theta, okay, by using tangent of theta equals y over x, and choose theta so that it lies in the same quadrant as x, y. And this a little bit goes back to what we were doing earlier with a ij form for vectors. Very, very similar. It will not give you the exact value. And again, I'm going to talk about this as my reference angle. I know they just talk about theta, but I'm going to say theta prime is going to equal inverse tangent. I'm going to do the absolute value of y over x. So this is always going to be an acute angle. Then if we're in quadrant 2, you have to take 180 minus theta prime. If we're in quadrant 3, you have to take 180 plus theta prime. And if we're in quadrant 4, you have to take 360 minus theta prime to get your angle. And now this, if you're in quadrant 1, the angles are equivalent. Theta equals theta prime. So that's the method I'm going to use here. All right, now we want to find the polar coordinates are in the form r theta of the point P, whose rectangular coordinates are negative 2, 2 square root of 3, where r is greater than 0, and we're going to use radians, zeros between 2 pi. And these are both going to be positives. Normally when we're finding polar coordinates, I know there's 4 different ways you can write it. We want them both being positive because that's what we're most familiar with. All right, just to have an idea, where is this point? Negative 2 square root of 3. Well, I'm just going to give what is 2 square root of 3 as a decimal, just so that I have an idea where it's at. About 3.5. So this is negative 2 and then about 3.5. So that is our point. And we want to find what the r value is, and we want to find what the theta is. Well, since we're quadrant 2, theta is going to have to be between 180 and 270, or pi over 2 and pi. And now that's your y value. That's your x. Well, what do we say r equals? R equals square root of x squared plus y squared. Just be careful here. R equals, when you plug that in, -2, make sure it's in parentheses, plus 2 square root of 3 squared. Well, -2 squared is 4. 2 square root of 3 squared. Don't forget 2 squared is 4. Square root of 3 squared is 3. That just ends up equaling 12. So I get 4 plus 12. Square root, that's 16. Square root of 16 is 4. So we get a nice number. Yes, you can type this straight into your calculator and it'll work as long as you don't screw it up. And don't screw it up. Plus, and then I would make sure that I have that, because it's just dealing with parentheses and making sure you have them in the right spot. And obviously I did something wrong because I did not square the 2 square root of 3. And so let's see if I can get it right this time. -2 squared plus, okay, 2 square root of 3. Okay, now I want to square that whole thing. And I probably need another parentheses. I don't know if it's absolutely necessary. All right, so it gives me 4. But here's the thing, if you do like I did, type it in wrong, it's easy to make a mistake. All right, my reference angle, theta prime, is inverse tangent, absolute value of y, 2 square root of 3 over that. Now that reduces, you can type it in just like that, but if you notice, and then I'm going to get rid of the negative because I'm taking the absolute value, those would cancel and you're really taking the inverse tangent as square root of 3. Now, even though we're in radians, I'm going to use my calculator and I'm going to keep it in degrees and then convert later. It's just easier. Yes, you can type it in as 2 square root of 3, okay, divided by 2. I'm going to get rid of that negative. 60 degrees. That is my reference angle. So that is this angle right here. So the actual angle, since I'm in quadrant 2, is going to be 180 minus 60 degrees, which is going to be 120. Well, what is that in radians? That is going to be 2 pi over 3. Because remember, 60 degrees is pi over 3. All right, so in polar form, r comma 2 pi over 3. So there you go. So we can convert from rectangular to polar, and now we can convert from, well, that's rectangular to polar, and earlier we did polar to rectangular. Got it? All right, so here's the first day of section 7.6. Here's your assignment. And I think on the directions, the book will tell you to plot the point. I'm not worried about that. Okay, we're going to do that more or less tomorrow. Just find the 3 other sets of polar coordinates. And like I said, I don't care which order you put them in, just as long as you have all 3 of them for that one. All right, you guys have a great day. Pop in Canvas Conference today if you get a chance to look at this and you got any questions, or if you got any questions over your test, make sure you go through that again. All right, everybody, have an awesome day.